Okay, page 30. All right. Yesterday we did product and quotient rule. The day before, we learned some new derivative rules. So involving like e to the x, natural log, and then sine and cosine. Today we're going to be looking at the rest of the trig function derivatives. So I like to line it up in this way. On the quiz, on the test, I would suggest that you write it out in this particular format. I think there's some nice connections between the derivatives that makes it easier to see in this. But that's just my suggestion. This is the way that I memorize it. So, but I also suggest on the day of the AP exam, I always tell students, when you get the multiple choice non-calculator test, go ahead and put these 6 rules at the top of the page, because next semester, or not next semester, but later on, we're going to do anti-derivatives, and we're going to work backwards from all these derivative rules. So there's actually 12 rules that's sitting here. It looks like it's only 6, but integral is just working backwards from these derivative rules. So there are ways that we can derive these derivatives, but I'm just going to focus on memorizing these. On the AP exam, you never want to spend time deriving a formula. You want to be able to get to the derivative and be able to use it. Okay, so let me go through these derivative rules. So sine's derivative we know is what? Cosine. Cosine's derivative is sine. Okay, so we know these, right? Now, sine and cosine, they kind of have that pattern with each other in the sense that they're just each other's functions. Now, tangent's derivative is secant squared x. Right. And cotangent's derivative is negative cosecant squared x. The connection between these two visually is that they're both the squaring of a trig function. Okay, so that's a common pattern. And you see that tangent is just using the function below it to arrive at the derivative. Same thing here. Cotangent is just using the function below it. Okay, so visually we see that symmetry from both sides. Secant's derivative involves itself and the one above it. So secant is just secant x tangent x. And if you had to guess, what do you think cosecant's derivative would be? Yeah, cosecant, cotangent. And if you look, all these are negatives here. So it's going to be negative cosecant x cotangent x. So I like to write it out in this form because the ones across from it have a similar pattern. And then tangent and secant involve each other. Cotangent, cosecant involve each other. And then one more thing is all the trig functions that start with c produces what? Negative derivative. So that's a nice pattern there as well. Okay, so we're going to be applying these derivative rules and then also look to see, is there a need for product rule? Is there a need for quotient rule? And then we're going to also bring in other functions that we've learned involving logs and exponential, and see if we can just put it all together. Okay, so this one's asking for the derivative of sine of x times tangent of x. What do you think we need here? Product rule, right? Sine and tangent are clearly independent functions. They're being multiplied by one another. Anytime I want to find the derivative of two things multiplied with each other, I have to go through product rule. Okay, so go ahead and try it, and I'll work through it at the same time you got to. Okay, any questions? One. Yeah, I'm not gonna, I'm not gonna worry about having to factor or clean up. Yeah, any variation of the derivative is good unless I specify that I'm looking for something. But typically, it's any variation is fine. Number 2, find f prime of pi over 6 if f of x equals x over secant of x. This is a two-step process. We first have to find what? Yeah, find the derivative, and then after we find the derivative, we can do what? Plug in pi over 6. And this is where we have to resolve the trig values. We can't leave something as cosine of pi over 6 or secant of pi over 6. So on the AP exam, they typically will let you leave your answer unsimplified. But if you leave your answer as sine of pi over 6, that's not good enough. You have to resolve it down to a ratio before you can leave it alone. So what rule can we use? Quotient rule. Is there a way to avoid quotient rule for this problem? We can also write this as what? X times cosine, because secant is same thing as 1 over, or secant is reciprocal of cosine. So if I bring that up as 1 over secant, that's really cosine. So we can either go through product rule here or go through quotient rule. Let's just go through quotient rule just for practice purposes, but just know that sometimes we have ways to use a different rule if we have it in a different orientation. But for practice purposes, let's just do the quotient rule. Okay, try that. I'm going to clean this up just so that if I plug in pi over 6, it'll be easier to clean that up. I know secant is related to cosine. Cosine of pi over 6 is root 3 over 2. So if I flip that, and then I don't mind if you leave your answer in complex fraction. AP College Board will also allow that. We just can't leave our answer in this. We have to resolve our and get it down to a trig ratio before we stop. That's right. If your answer are numeric numbers, you can leave it in any form. If there's any trig sticking out, we got to go further, right? That's not simplified enough. Okay, try number 3. What would you use for number 3 to find the derivative? What rule? Product rule. Okay, try that. Questions with 3. Okay, number 4, we see numerator denominator. We could go through quotient rule. It's not an issue if we do, but is there a way to avoid quotient rule here? Okay. How would you rewrite this function where we can avoid quotient rule? Yeah, the 2, we're not gonna move the 2, but we can move that cosine. We can move that cosine up. We know the reciprocal of cosine is secant. So if we think of it as 1/2 secant x, then we can just apply that derivative. There's no right or wrong way. I just want to give you options. And then, the more options you have in front of you, when the time comes, you can make the decision that will best fit what you would like. Change from cosine to secant, right? Because we know that cosine is the same thing as 1 over secant. So think of this as the same thing as 1 over 2 cosine of x, the same thing as 1/2 times how about this? 1 over 2 cosine x, same thing as 1 over 1 over secant of x. And if I flip that secant up, it'll become 1/2 times secant of x over 1. Yeah, so since the reciprocal of cosine is secant, cosine is secant, secant is cosine, we can flip it out. But if you went through quotient rule in this form, you'll still get the same. Or it may look a little different, but it'll still be essentially the same derivative. Okay, let's work through all of page 31. And I'm going to have you guys try each of them, and then I'll just show the answers and So we can pace our work, get comfortable with these. Okay, try number 6 if you're good with 5. Okay, next up, find equations of both the normal and the tangent line. So tangent line just means you're going to find the derivative, find the slope, and then whatever slope number you get, that will be the slope that you want for that tangent line. And normal line means perpendicular. So after you find f prime of that value, you got to take the opposite reciprocal and let that be the slope of your perpendicular line. sometimes if you realize that you have lines that are horizontal and vertical, easiest to just draw it out. Then, sometimes with slope intercept form, it doesn't quite work as cleanly as you would like. I think it's easier to just, it's horizontal line, vertical line, they're perpendicular, and it's easier to just draw the graph and name the graph. So whether you're using a tangent line or normal line, your order pair will stay the same. You're just adjusting to a new slope. Okay. Are we okay with 7 and 8? Okay. 15 and 16, find equation of tangent line. So find the derivative, find the slope, find your order pair, and then point slope form. And or number 8. So if I want to find the perpendicular slope, I'm gonna make some adjustments to that number. I'm gonna take the reciprocal and I'm gonna change the sign. So it's really 4/1. Reciprocal 4/1 is 1/4, and I change it. That way it'll make the two lines perpendicular. Now, again, normal just means perpendicular.
Please, are we gonna problems here? Just like find an equation that in your mind and then graph the equation and the function.
No, I'm not gonna ask you the graph. But I do think, if it's horizontal vertical line, to me, it's easier to just graph it and name the function. But typically, I'm not gonna ask you, I won't ask you to graph line. So as you guys are working through 15 and 16, 16, we do need to apply the derivative rule for e to the x that we learned a couple of days ago. So e to the x is just e to the x. Okay, so for the remaining time in class, I'd just like for us to work through the AP practice problems starting on page 33 and see how much we can get done. And then I will walk around, see if I can answer any questions, and then I'll go through each of them as well. Once we're done with this page, we're gonna work on some of our homework together. Page 30. Yes, I'll give it back to you tomorrow. I'm trying to do the Canvas grade pass back. So I'm gonna try to learn how to enter the grade in. But even if I can't get that, I'll hand those tests back to you tomorrow. Okay, does anybody still need this page? Okay, page 33. Notation. If you see this dy dx, that is another way of saying f prime or y prime. It's more descriptive in the sense that this is saying find the derivative of my dependent variable y with respect to my independent variable x. So it's more descriptive in that way, but it just means find the derivative. We do, but it's always in relation to, no, yeah, we always find the derivative of the dependent with respect to our independent variable. Yeah, there's always two variables involved. Okay, so number one, we can use what rule? Product rule. Number two, what does that look like to you when you see this? That reminds us of general limit definition of a derivative, right? So let me write out that definition so we kind of see. We're not going to work this out. We're more going to look to see what is this asking us to find, and then we're going to use our derivative rules. Now, if you look, all the x values here have been replaced with what? Pi over 3, right? So let me rewrite it using pi over 3. The hint is really coming from over here, right? Can you tell what function is getting plugged in? Cosine of x, right? So that's really telling us what our f of x is. Our f of x is cosine of x based off of the fact that is what's getting inserted in. But we're looking for f prime of pi over 3. So now that we know what we're starting with and what we're trying to find, we can leave this behind and just focus on what we're starting with and what we need to end with. Now we can rely on our derivative rules, right? What's cosine's derivative? Negative sine. And now I can do f prime of pi over 3 by replacing the x with that. So this is kind of more of a, this is how a general definition could be used on the AP exam. You're never going to be using it to find the derivative. It's more, can you recognize what the limit definition is telling you and then pull that information from there. Yes.
Of function cosine of pi over 3.
Well, that pi over 3 is basically telling us that this x is getting replaced with pi over 3. And because that x is getting replaced, then this left side is really informative because, oh, I'm just looking for f prime of pi over 3. So that must mean the slope of this derivative at that point. Yeah, exactly. Right. Understand this is talking about f prime of something, either f prime of x or f prime of an x value, which in this case, pi over 3. Okay, let's see if we can do 3 and 4, and then we can stop for the day. 3 is pretty straightforward. Find the derivative, plug in pi over 3. And number 4, you see the mention of position, velocity, and acceleration. So those are going to be f of x, f prime, and f double prime in that relationship. So the derivative of position is velocity, and the derivative of velocity is acceleration. Because acceleration is the rate of change of velocity. So we just have to, we can find each of the 3 derivatives one after the other. So number 4, we find the velocity function, which is just the derivative of position. Sine becomes cosine, t squared becomes t, 8 goes to a 0. We have to go another level down. So velocity's derivative is acceleration. Cosine's derivative is negative sine. 3t becomes 3. What is the velocity when acceleration is first equal to 0? So this is telling us what to do. We're going to set acceleration equal to 0. And then once we find the time where that occurs, we can find the velocity at that moment in time. So I set 0 equal to the velocity function. Sine of t equals 1/2. Inverse trig, t is inverse sine of 1/2. So t must be equal to pi over 6. Once I know the moment in time, now I can just figure out how fast is this object moving at this moment in time. So we do velocity at pi over 6. We have our velocity function, insert in, resolve these trig values, and then match our answer choice to C. Okay, check your calendar for your homework. Come get your phones.
It's on the.
It's not on the quiz. No, we'll do that. We'll do that next week.
You know, like the things in your head, like they're like by the velocity will be a certain value at the same time that acceleration is zero. We need to find v from your